So good day everyone and welcome back to our YouTube sessions. Today we are going to be talking about addition reactions, as you can see the topic on the board. So at this point in time, let's just get into the reactions. We still continue. So for those who have watched our previous videos, I'm sure you have seen that we published about 2 or 3 videos regarding some other types of reactions, which is addition, which is substitution reactions, and also combustion reactions. So today I just want us to continue and focus on addition reactions, just to try and investigate some principles on how does those reactions take place and what should we expect, what is not expected. So for addition reactions, we have mainly 4 types of addition reactions, but the first one that we shall start with is the first one that we shall call halogenation. So halogenation here, this is going to be the reaction of alkenes. So let's go deeper into this. Almost all of them, addition reactions, those are reactions of alkenes transforming into different molecules. So mainly every time we shall talk about addition reactions, it's all about alkenes. So the first one, which is halogenation, let's get the model right. Our model right is that alkenes in this case, for halogenation, they react with the halides. When they react alkenes with halides, then what is going to be formed? These are haloalkanes. We get haloalkanes when alkenes react with halides, which is our gases in gaseous state. So let's have an example here of an alkene. An alkene, for example, if we have an alkene made up of 4 carbons, which is going to be, in this case, let's just have this alkene, which is butene 1. This is going to be butene. This is butene 1. So butene 1 is going to react. In this case, let's have bromide gas. Let's have reacting with bromide gas. So we just want to understand how is haloalkane formed from a reaction between alkene with the bromide gas. So how this reaction is going to take place is that if you check here, we have 2 atoms. This is a 2. We have 2 atoms of bromide, and in this case is an alkene. So most importantly, in these reactions, what is important is that there is a double bond on the alkene, meaning to say our compound is unsaturated. So this alkene, the double bond is going to be broken. But how is it going to be broken? Since we have 2 atoms of bromide, one atom migrates itself to attach itself to this carbon, another atom migrates itself to attach itself to this carbon, thereby breaking the double bond. So we are going to have a haloalkene with the 4 carbons, but those bromide atoms, they attach themselves to these 2 carbons here. So once they attach themselves, we no longer have a double bond. As you can see here, we now have single bonds all over. This is how a haloalkane is formed from halogenation, mainly from the alkene here. So this was butene 1 reacting with the bromide gas, and the result that we have here is we have 1, 2, because when we are naming this, we name from we need to give number to our functional groups, which is in this case the bromide atoms. So we have 1, 2, then dibromobutane. We have 1, 2, dibromobutane. This is how halogenation in addition reaction take place. So as you are going to study, when you are studying this, do not confuse this with haloalkane, with haloalkanes which are formed from halogenation, which is of substitution reaction. So this is how we make haloalkanes from alkenes. So we move on to the next group, which is halogenation. Let us see how does halogenation take place. So what we are going to have, halogenation. After halogenation, let's also take a look at hydrogenation. Hydrogenation. How does hydrogenation take place? So hydrogenation, from the word suggests hydrogenation, which is addition of hydrogen gas to an alkene. So the model is such that we have an alkene. This alkene reacts with hydrogen gas, and when they react, we are going to make alkanes. Straight chain alkanes are made from a reaction between alkenes and hydrogen, which is in gaseous state. So let us have an example of an alkene. Our alkene is going to be of this form. Let's have the same alkene that we used previously, and this is our alkene. This is our alkene. The double bond is here. So what you want to see now is when this alkene reacts with hydrogen gas, how is an alkane going to be formed from them? So the alkane is formed in this way, whereby you can see properly that we have two atoms of hydrogen in this case. So two atoms of hydrogen, both of them are going to be added. Hence, that's why we call them addition reactions, because both of these atoms are going to be added to these two carbon atoms here, thereby breaking the double bond. So both of them, one hydrogen atom comes here, another hydrogen atom comes here, which means the double bond already it's broken. Double bond is broken. What we now have is an alkane. An alkane is formed. So we had this was butene 1. So after the butene 1, then it's butene 1 reacted with hydrogen gas, and the result that we have is that we have butane. Butane is formed from these two. So this is how basically hydrogenation takes place, and this is also a process of hydrogenation in real life. From the studies, from the case studies, is that this is the process which is also used in hardening of margarine, hydrogenation process. So in this case, this is how we deal with hydrogenation and halogenation. So thank you so much for watching. Keep on subscribing, keep on pressing the notification buttons, so that at least when we post more content and more videos, you will be able to view them as we shall post them from time to time. Thank you.